Okay. Right, we face a technical problem. Now it is correct. Okay, right? Now look at here. We couldn't get a connection. Then that's the reason. Right now, matrix A order. If you write the order of matrix A, order of matrix A is one. Oh, sorry, two rows and one column. Order of matrix B is three rows and one columns. Order of matrix C is four rows and one column. Now look at the number of columns of these matrices. Number of columns of the matrix 1. Number of columns of these three matrices is 1. Therefore, we can write here general form. In generally, the order of a column matrix, number of rows may be changed. Number of rows mean the different values can be given. So in number of columns of the matrix, number of rows of the matrix may be different, but number of columns of the matrix should be 1. Then, in generally, order of a column matrix is represented by n by 1. Then write down. In general, the order of a column matrix is n by 1. In general, the order of a column matrix is n by 1. In general, the order of a column matrix is n by 1. In general, the order of a column matrix is n by 1. Then again I have given a center here. A column matrix is also called a column vector. Now the row matrix is called row vector. Column matrix is again called a column vector. Vector. The word is vector. Row vector and column vector here. Right. Now we will go to third term now. Now I said you what is meant by row matrix, then column matrix. Write down third type of matrices. Third type. Third type of matrices, right? That type is called zero or null matrix. Third type of matrices. Zero matrix. Zero or null matrix. Zero or null matrix. The next type write down zero or null matrix. The third type is called zero matrix or null matrix. Now write the meaning. Write the meaning. A matrix having a matrix having a matrix having every elements a matrix having every elements equal to 0. A matrix having every elements equal to 0. A matrix having every elements equal to 0 is called a zero or null matrix. A matrix having every element equal to 0 is called a zero or null matrix. Now, null matrix or zero matrix is a matrix. All the element of the matrix should be 0. Any order, and we don't consider about the order this time. Any order, but when all the elements are 0, that is a null matrix or zero matrix. Then write down some example. A equal, that is a column row matrix, that is a row matrix, that is a null matrix. That is a row matrix, that is a null matrix. Then B equal, There is a column matrix, that is a null matrix. When there is a null matrix, all the element of the matrix should be zeros. Two zeros, a row matrix. Here, column matrix. Third example, write in this way. Third example, all the element of the matrix are zero. That is a null matrix. Here, two rows and three columns, but there is a null matrix. Then three examples for null matrices. Null matrix is a matrix with uh, zeros. All the element of the matrix should be zero. Any order. We don't consider about the order of the matrix. We know that all the element of the matrix are zeros. Right. Try three examples, then we go to next time. That is more difficult to understand. Null matrix or zero matrix. Next type. Fourth type, write down. You can write any matrix, but elements of the matrix zero mean all the elements. When all the elements of the matrix zero, that is a null matrix. So, zero matrix. Next one. Fourth type. In the paper, I have given rectangular matrix, but I asked you to write square matrix. Anyhow, we will write square matrix. According to the note, we will write fourth type square matrix. Write down fourth type square matrix. You can get an idea about this one because square matrix, the new type of matrix called square matrix. In the paper, I have explained you all the type of the matrices, the definitions given. But when you write the definition, we want to write what is how can you represent that definition using example. Therefore, when I explain you the theory for all these type, I will give you three examples. Now the next one, square matrix. Write the meaning. Write the meaning of a square matrix. A matrix in which, then look at the paper, a matrix in which, a matrix in which, a matrix in which the number of rows are, the number of rows are equal to the number of columns. A matrix in which the number of rows are equal to the number of columns. Then square matrix mean a matrix in which the number of rows are equal to the number of columns. The number of rows are equal to the number of columns is called a square matrix. The number of rows are equal to the number of columns. Then write down first example. Square matrix mean A. Now you can write any capital letter, right? I will write here P. P equal. The first square matrix when you write, it should have two rows and two columns. Same number of rows and column. I told you we don't write a matrix with one element at the beginning. When you write a matrix with four elements, that is the first square matrix. So elements represent 2, 3, minus 1, 4. That is the first square matrix. First square matrix should have two rows and two columns. Then number of elements of the matrix should be 4. The second square matrix 2, 1, 3, 4 minus 1, 6, minus 5, 0, 2. That is also a square matrix. Write it. Not difficult to identify or understand. Square matrix means number of rows and columns of the matrix should be equal. 2 rows, 2 columns. 3 rows, 3 columns. I told you I will give you 3 examples first of all these type of matrices. Third one, R. Matrix R represent elements 4103, any number we want to write here without thinking about the value, write them 562 minus 1 3 4 7, 5, minus 6, 3, 6, 0. That is the fourth square matrix. Actually, when you do calculation with the square matrices, no need to use this type. We are using element matrix with 4 elements only in your textbook. If you have read examples and the question they have given, always they have used square matrix of order 2 by 2, not given 3 by 3 and 4 by 4. But write it when you write the example. We're going to write 3 examples for one type of matrices. So square matrix mean the first one, first square matrix, write the order 2 by 2. Second square matrix, order 3 by 3. Third square matrix, order 4 by 4. When there is a square matrix, number of rows and columns of the matrix should be equal. Write down example for square matrix 2 by 2, 3 by 3, then 4 by 4. The square matrix of order 2 by 2, 3 by 3, and 4 by 4. Right. No need to write anything about that order, then you know that the same order, that means 2, 2, 3, 3, 4, 4, like that. When you are doing sums, no need to do calculation with 4 by 4 and 3 by 3 matrices. We want to learn about 2 by 2 square matrix. Rarely we get question in this order 3 by 3, not given sums in the order of 4 by 4. We don't do this calculation. Right. For fifth one, fifth type. Fifth type. Write down the fifth type of matrices. The next type, rectangular matrix. Write down rectangular matrix. Rectangular matrix. The next type of matrices, write down rectangular matrix. Write the type of the matrix, rectangular matrix. The next type, rectangular matrix. Then write the meaning. Rectangular matrix, write the meaning. A matrix in which a matrix in which a matrix in which the number of rows a matrix in which the number of rows a matrix in which the number of rows are not equal a matrix in which the number of rows are not equal the number of rows are not equal to the number of columns. A matrix in which the number of rows are not equal to the number of columns is called a rectangular matrix. The number of rows are not equal to the number of columns is called a rectangular matrix. Right. Now write down some example. First one, matrix X. Rectangular matrix mean rows and columns are not equal. Therefore, if you write a row matrix, that is a rectangular. If you write a column matrix, that is a rectangular. But we will write here more than elements given in row matrix and column. 2, 3, 1, 4, 1, 6. That is a rectangular matrix because the number of rows of the matrix 2, the number of columns of the matrix is 3. Number of rows and columns are not equal mean that is a rectangular matrix. Example 2, y. The capital letter is represented the matrix here. 2, 3, minus 1, 5, 4, 6. That is also rectangular matrix because the number of rows of the matrix 3, the number of columns of the matrix 2, the number of rows and columns are not equal mean that is a rectangular matrix. Third example, I will name that matrix as Z, capital letter we use. Then the elements when you represent 3 to 5, 4 minus 1, 0, minus 2, minus 3, 6. Right? Then these three examples for rectangular matrices. Write the order of the matrix. First one, order of the matrix is 2 rows and 3 columns. 3 rows and 2 columns. 3 rows and 3 columns. Sorry, this is square matrix. So I want to add another element. 0, -1, 4. Now there is a rectangular matrix. So, order of the matrix is 3 rows and 4 columns. When there is a rectangular matrix, number of rows and columns of the matrix should not be equal. If they are not equal, there is a rectangular matrix. So look at here, 2 by 3, not same rows and columns, 3 by 2, then 3 by 4. Try examples for rectangular matrices. When you write a rectangular matrix, number of rows and columns, they are not equal. Very easy to understand. Now you know row matrix. A matrix which has only one row is called a row matrix. Column matrix. A matrix which has only one column is called a column matrix. The next one I have explained you null matrix or zero matrix. Null or zero matrix mean any type of matrix. That means we don't consider about the number of rows and column, but all the element of the matrix should be zero. The next one, square matrix. How can you identify number of rows and number of columns of the matrix should be equal? The order of the square matrices 2 by 2, 3 by 3, 4 by 4 like that. Then the next type is rectangular matrix. Rectangular matrix means number of rows of the matrix and number of columns of the matrix are not equal. So here 2 by 3, 3 by 2, 3 by 4. They are rectangular matrices because the rows and the columns, number of rows and the columns are not equal, right? Now, sixth type. That is somewhat difficult. That means difficult means the different type. The sixth one, right? Unit matrix or identity matrix. Sixth type, write down. Unit matrix. Sixth type, unit matrix. Unit matrix O, that is again called identity matrix. Unit matrix O, identity matrix. The next type, unit matrix O, identity matrix. Unit matrix O, identity matrix. Identity matrix is represented by capital I. Represent that matrix by a letter capital I. Identity matrix, when you want to represent, you can represent I. In your syllabus also they have given it I. Now look at the definition. That is the biggest definition out of these matrices type. First, look at here, a square matrix. First, you want to know identity matrix is always a square matrix. If there is a square matrix, order of the identity matrix is always 2 by 2, 3 by 3, or 4 by 4. Because identity matrix is a square matrix, mean order should be 2 by 2, 3 by 3, 4 by 4. In a square matrix, rows and columns are equal. So in identity matrix also, rows and columns should be equal. Then the square matrix in which the diagonal element, when you represent a square matrix, there are two diagonals. If you write a square matrix or rectangular matrix, there are two diagonals, but we are considering about square matrix. You know what is mean by diagonal. In if you define diagonal using quadrilateral polygons, diagonal mean in a quadrilateral when you join two opposite vertices, that is the diagonal. So when you write a square matrix, there are two diagonals like this. Then out of the two diagonal, one diagonal is a main diagonal. Two diagonals, one is a main diagonal. Then look at here, main diagonal they have defined top left to bottom right. Then when you write a square matrix, there are two diagonal. One diagonal is a main diagonal, that is top left to bottom right. Now I will explain you on the board. Are each equal to units. then all the elements represented on the main diagonal should be units, that means ones, and all the other non-diagonal elements, the other elements not represented on the main diagonal are equal to 0. It's called a unit matrix or identity matrix. Then first write the meaning. Look at the paper and write the meaning. If you don't have the paper, I will read out this way. A square matrix in which the diagonal element a square matrix in which the diagonal element a square matrix in which the diagonal element within bracket top left to bottom right close bracket are each equal to 0, sorry, units are each equal to units and all the non-diagonal elements are equal to units and all the non-diagonal elements are equal to units and all the non-diagonal elements all the non-diagonal elements all the non-diagonal elements all the non-diagonal elements are equal to 0. All the non-diagonal elements are equal to 0 is called a unit matrix or identity matrix. All the non-diagonal elements are equal to 0 is called a unit matrix or identity matrix. Right, now look at here. Because when you get a question about identity matrix or unit matrix, they will give you order. Then if they say unit matrix of order 2 by 2, you should be able to write it. Because you know that unit matrix is a square matrix. So look at here. Now you have write the definition. First unit matrix. If you write the first unit matrix, the order of the first unit matrix should be example 1. Order of the first unit matrix should have order of the first square matrix. Order of the first square matrix is 2 by 2. Then if you write identity matrix of order 2 by 2, identity matrix of order 2 by 2 means it has 4 elements. First, I will write in this way. There are 4 elements in the matrix. There is an identity matrix or unit matrix of order 2 by 2 means it has 4 elements. Now I say to these are the 2 diagonals. Here is one diagonal. This one is the other diagonal of the matrix. I don't write elements still. Now, out of these 2 diagonals, we want to identify main diagonal. Main diagonal mean that is from top left to bottom right. Top left, the diagonal extend from top left to bottom right. Then identify out of these 2 diagonal which diagonal is represented by top left to bottom right. Top, bottom, top left to bottom right. So this is a main diagonal. I will remove the other diagonal. We want to identify what is the main diagonal of the matrix. Main diagonal means top left to bottom right. The elements in the main diagonal, they are units. Elements in the main diagonal are units. Elements in the main diagonal are units and all the other elements of the matrix should be 0. So this is a first unit matrix. Unit matrix or identity matrix of order 2 by 2. That is a square matrix and elements from top left to bottom right, they are ones and other element of the matrix should be 0. Right. Now try to write yourself as a second example. Try to write identity matrix of order 3 by 3. The next square matrix should be in order 3 by 3. Now write elements of identity matrix of order 3 by 3. Write the element. You know that 3 by 3 means there are 9 elements. Altogether 9 elements. Then you want to identify main diagonal. Identify main diagonal of the matrix. That is matrix of order 3 by 3. That is a square matrix. Now represent element. First you want to represent element top left to bottom right. They are units. All the other elements of the matrix should be zero. Right? Now I write the next one. Complete these two. Example 3. Identity matrix of order 4 by 4. Write it clearly. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. You don't want to represent uh, uh, the points. You don't want to represent this blank. Without representing blanks, you can write the elements. I will represent blanks, then I will complete the blanks. No need to represent blank. Write down next two identity matrices, because if they give identity matrix of order 2 by 2, you should be able to write. This is identity matrix of order 2 by 2. This is identity matrix of order 3 by 3. Here 4 by 4. Now write the elements of these three matrices. Identity matrix of order 2 by 2, 3 by 3 and 4 by 4. Write the element in these three matrices, identity matrices of order 2 by 2, 3 by 3 and 4 by 4. Identity matrix of order 2 by 2, 3 by 3 and 4 by 4. Write the matrices. Right. Now I will complete the second one. Identity matrix of order 3 by 3. Main diagonal. Elements in the main diagonal units. Elements in the main diagonal unit and other elements of the matrix should be zeros. Main diagonal units and other elements of the matrix should be zero. Then here ones, units, all the other elements of the matrix should be zero. Identity matrix of order 4 by 4. Again, elements in the main diagonal. Main diagonal elements are unit. Main diagonal means top left to bottom right. Elements in the main diagonal unit. All the other elements of the matrix should be zero. All the other elements of the matrix should be zero. Now represent identity matrix of order 2 by 2 and 3 by 3, 2 by 2, 4 by 4 and 3 by 3. They are identity matrix of order. This one 2 by 2, 3 by 3 and 4 by 4. Right, the last type of matrices that is not given in my paper. I didn't given that one, but that is in your syllabus. That is a new matrix type added to your syllabus. Therefore, in the new syllabus they have added. Write down next type. This one's okay. Type 7. Type 7. Symmetric matrix. Type 7. Symmetric matrix. The next type, write down symmetric matrix. Symmetric matrix. The new type of matrices is called symmetric matrix. Symmetric matrix. Right, write down the meaning, write in this way the meaning. I didn't given that meaning on the paper, write down this way. The elements, write the meaning. the elements, the elements around the main diagonal, the elements around the main diagonal, the elements around the main diagonal which are equal to each other. I will explain you. The elements around the main diagonal which are equal to each other, which are equal to each other are placed symmetrically, which are equal to each other are placed symmetrically about the main diagonal, are placed symmetrically about the main diagonal. The elements around the main diagonal which are equal to each other are placed symmetrically about the main diagonal, about the main diagonal. The elements around the main diagonal which are equal to each other are placed symmetrically about the main diagonal, about the main diagonal is defined as is defined as is defined as symmetric matrix, is defined as symmetric matrix, is defined as symmetric matrix, is defined as symmetric matrix. Then I couldn't tell you. First, you want to write it again. When you write the definition, write down again this way. Symmetric matrix is a square matrix. Symmetric matrix is a square matrix. Symmetric matrix is a square matrix. Now you know that unit matrix is a square matrix, symmetric matrix also square matrix. Then look at here, try to identify that, not difficult. Symmetric matrix. Symmetric matrix is a square matrix. Then first one, example 1. We have to use a capital letter to name a matrix. Matrix should be named using capital letter A. A is a symmetric matrix, so that should be a square matrix. Then the elements in the main diagonal. Elements in the main diagonal we have to represent like this. But they are the elements in the main diagonal may not be equal, then they are not same. This is the element of the main diagonal. But the elements in the main diagonal is here. The other two elements. Then when you get the other two elements of the matrix should be equal. Then they have explained here around the main diagonal. There is a main diagonal. The main diagonal, then the other elements around the main diagonal should be equal. Then the corresponding places should be same element. In the corresponding places, when you represent same element, that is a symmetric matrix. This one is a main diagonal. We don't consider about the elements in the main diagonal. Any elements may be in the main diagonal of this square matrix, but the other elements should be equal. Corresponding places around the main diagonal elements should be equal. Then this line become like a symmetrical line. This line becomes symmetrical when they are equal. So this is called symmetrical matrix. Second example. Example 2. Matrix B. Matrix B, the next square matrix. I will write here the next square matrix. The next square matrix is order 3 by 3. Then diagonal, main diagonal. Any elements can be represented in the main diagonal. Now there are some elements should be represented on these places. We know that there are 9 elements in a square matrix of order 3 by 3. This is square matrix order 3 by 3. There are 9 elements. 9 elements. I have represented elements in the main diagonal. Then around the main diagonal. around when you get the two sides of the main diagonal, the elements should be equal. Same element should be represented on two sides of the main diagonal. Now this is main diagonal. This is main diagonal. We want to mark, sorry, here, we want to mark same element around the main diagonal. Now how can you mark this? Here, I will mark element 4 here. So this is a main diagonal. Here should be 4. These two elements should be equal. Again, the element in this place I will write -5. Then the element here should be -5. This line is work as a symmetrical line in a symmetrical matrix. Then around the symmetrical line, the elements on two sides should be equal. Same places represent same element. Here, first row, second column. Here, first column, second row, same element. First row, third column. First column, third row, same element. Here and here also, we want to represent same element. Then, around this main diagonal, when the elements are equal, that is called symmetrical matrix. When this is the main diagonal, around the main diagonal, element represented on two sides should be equal. Then same places, same element, symmetrical places, same element. 4 and 4, -5 and -5, 0 and 0. Here also -1 and -1. Right. Now I have explained you what are the type of the matrices. Then the more than half of the lesson already we have completed. We didn't do sum fraction. We didn't do sums. Still, I told you the number of periods allocated for this lesson is 8 periods, 8 period lesson. So if we complete this lesson with all the theory part of the lesson, we should get 8 period to complete the lesson. Otherwise, we didn't complete it correctly. Because you know that I have given here 24 model fractions. Then again about multiplication, that is the important part. There are 20 sums about multiplication. Then past papers from 2008 to 2019, there are 13 fractions. So one theory part I want to complete. I told you I will do this lesson 3 hours. I will get a minute interval. Before that, I will complete the next theory part of the lesson. Write down next subtopic. Look at the paper and write the subtopic. Next subtopic, write down. Next subtopic, equality of matrices. Subtopic, write down equality of matrices. Look at the paper, the next theory part in the first page. The next theory part, write down equality of matrices. It is better to write the note because I told you when I explained this theory, I didn't give an example. If I write the examples here also, no need to write on the board. But when I explain it, you will understand then giving examples on the paper. That is why I will explain you about the theories, right? When I do sums, all the calculations I will do. Then write down equality of matrices. Then write in this way. Look at the paper and write. Two matrices are said to be equal. Two matrices are said to be equal. Two matrices are said to be equal. Two matrices are said to be equal if and only if two matrices are said to be equal if and only if two matrices are said to be equal if and only if they are of the same order. If and only if they are of the same order. Two matrices are said to be equal if and only if they are of the same order. And each element in the first is equal to 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 corresponding element of the corresponding element in the second. Each element in the first is equal to corresponding element in the second, right? Then I will explain you example. Now think that two matrices are equal. Two matrices are equal. Then first we want to know order of the two matrices should be equal. Order of the two matrices should be equal. Then look at here. I will write matrix A. I will write a square matrix of order 2 by 2. I will write a square matrix of order 2 by 2. Element x2 x2 minus 3 y. Then matrix B I will write matrix B, matrix A x2 minus 3y. Matrix B 1 set W minus 4. Then these are the elements. First you want to know, now I want to tell you that matrix A and B are equal. If I say A and B are two equal matrices, I want to know that order of the two matrices should be equal. You have seen order of matrix A 2 by 2, order of matrix B 2 by 2. Therefore, these two matrices are in the same mode. Then the first condition correct. Then matrices should be in the same order. Now I will write if A equal B. Now I have given matrix A and B are equal. If they are equal, order equal. Now I will write matrix A x 2 minus 3y equal matrix B 1 set W minus 4. Two matrices are of the same order, then the matrices are equal. Two matrices in the same order, therefore I will have given here they are equal. Now, when they are equal, if these two matrices are equal, corresponding elements should be equal. When the two matrices are equal, corresponding elements should be equal. That means, look at the corresponding element x equal to 1. So, x equal 1. Then, set d equal to 2, corresponding element. Set d equal to 2. Then, this one. W equal to minus 3. W equal to minus 3. Corresponding element. X equal 1. When A and B are two equal matrices, X equal 1, Z equal to W equal minus 3 and Y is equal to minus 4. Then when two matrices are equal, we want to know that two matrices should be in the same order and corresponding elements should be equal. Write down about two equal matrices. Equal matrices mean two matrices should be in the same order and corresponding elements of the matrices should be equal. When you do sums given on the paper, you will be able to identify these theories. Now we know that two matrices are equal mean corresponding elements of the matrices are same. Corresponding elements are equal. Then that's difficult to complete all the syllabus, all the theory part of the lesson. Then we will do sums. First part, I will do the first all the theory part in the first page. Then the second, after that we will do sums. Today we can complete these sections. Then the multiplication of matrices. After that we want to know all the theory part and the questions we can complete in one day. Right. Then write down. So okay, now you know that A and B are two equal matrices mean order equal. When the order and matrices are equal, the corresponding elements should be equal. When we do sums, we apply this theory in most section. Right. Now write down subtopic. Subtopic. Addition of two matrices. For these type of sums, I will give you one example because they are not difficult. Right? One example for one type. Write down addition of matrices. Subtopic Addition of matrices. Subtopic of the lesson. Addition of matrices. 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 Then write in this way. Look at the paper and write down. Write down. Two matrices can be added. Two matrices can be added. Two matrices can be added. Addition of matrices. Then write. Two matrices can be added. Two matrices can be added if they are of the same order. Two matrices can be added if they are of the same order. Look at the paper and write it. Two matrices can be added if they are of the same order. Two matrices can be added if they are of the same order. The corresponding elements are added one by one. 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 The sum of the matrices, the sum of the matrices, the sum of the matrices is also of the same order. The sum of the matrices also of the same order. The sum of the matrices also of the same order. Then what is mean of this? If you want to add two matrices, the order of the two matrices should be equal. The corresponding elements should be added, and when you write the answer should be in the same order. Actually, this is very easy to understand, but when you complete the syllabus, all the theory parts we want to do. That is the important part of your lesson. Addition. Now look at here. I will write matrix A. Matrix A 2 minus 3 5 1. Then matrix B. Matrix B equal minus 1 0 2 minus 4. Then A and B are two matrices. You have seen the order of these two matrices are equal. Matrix A, order 2 by 2. Matrix B, order 2 by 2. If these two matrices of the same order, we can find A and B. So, A plus B. I want to add two matrices. When I write the first example, I will write all this step of the calculation, but after that, no need to write in this way. Matrix A, matrix B. Now, corresponding element of the two matrices should be added. So, A plus B equal first element of the first matrix, first element of the second matrix should be added. Then first row, second column element should be added. Then second row, first column element should be added. Then corresponding elements mean second row, first column, second row, first column, first row, first column, first row, first column, first row, second column, first row, second column, second row, second column, second row, second column. We want to add a corresponding element. Corresponding element of the two matrices are added. 2 plus minus 1, minus 3 plus 0, 5 plus 2, 1 plus minus corresponding element. Then answer should be 2 plus minus 1 is plus 1. Minus 3 plus 0 is minus 2. 5 plus 2 is 7. 1 plus minus 4 is minus 3. So answer 1 minus 2, 7 minus 3. Then matrix A order 2 by 2, matrix B order 2 by 2, matrix A plus B order 2 by 2. That is a rule. Matrix A 2 by 2, matrix B 2 by 2. Then only we can add A and B. When you add A and B, A plus B also in the same order 2 by 2. Write it. Then you want to add matrix A and B. As one example, we want to write here. No need to write more example because that is not difficult to understand. When you added A and B two matrices should be in the same order. Then corresponding elements should be added. When you write A plus B in the simplest form, that matrix should be in the same order of A and B matrices. Then we will write. I want to complete another two theories we want to complete, then we will get a break. Second one, second type, third type here. Now we have learned about equality of matrices, then about addition of matrices. Now write down subtraction of matrices. Write down subtraction of matrices. Subtraction of matrices. Subtraction of matrices. The next type, subtraction of matrices. Subtraction of matrices. Subtraction of matrices. Now write it. Two matrices can be subtracted. Write the note. Two matrices can be subtracted. Two matrices can be subtracted. Two matrices can be subtracted if they are of the same order. Two matrices can be subtracted if they are of the same order. Two matrices can be subtracted if they are of the same order. The corresponding elements the corresponding elements are subtracted one by one. 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 The matrix obtained as a result should be the matrix obtained as a result also of the same order. According to the paper I have given, the matrix obtained as a result also of the same order, right? We will do the same question. Now no need to write A and B again. You have given A and B in the previous theory. Now we want to do A minus B. Write down. Separately write now as an example. No need to write A and B again. Write A minus B. A minus B. A minus B means matrix A minus matrix B. Now, corresponding elements should be subtracted one by one. In the previous calculation, corresponding elements are added. Now, corresponding elements should be subtracted one by one. Now, write the answer. Write the answer. Two matrices A and B. Corresponding element of the two matrices should be subtracted. Matrix A 2 by 2, matrix B 2 by 2. Same order we can add to subtract. We did addition in the previous theory. Now we are going to do subtraction. Now subtract two matrices and write the answer. Matrix A minus B. We want to do only to write the answer, right? We want to do only two theory part of the lesson. One is multiplication of a matrix by a scalar. The next part I have given separately on your paper, matrix multiplication. Now today I will complete the next theory part and we will try to do these fractions. If you can complete all these fractions given in the paper, that is enough, right? The matrix multiplication we can't do today. That means matrix multiplication. Multiplication of a matrix by a scalar we can do. The first the theory part I will complete. The next part we will do next day. Right. A minus B. Matrix A 2 minus 3 5 1 minus 1 0 2 minus 4. Then matrix A and B we have to subtract. Then corresponding elements of the two matrices should be subtracted. And we will subtract. Look at the answer. 2 minus minus 1. 2 minus into minus plus 2 plus 1 is 3. Minus 3 minus 0, that is minus 3. Minus 3 minus 0 is minus 3. 5 minus 2 is 3. 1 minus minus 4. 1 minus into minus plus 1 plus 4 is 5. Then answer 3 minus 3, 3, 5. The order of the matrix A minus B also 2 by 2. 2 by 2, 2 by 2. Then this one also 2 by 2. Right, the last theory part. We will complete the theory part here, then I will get 10-minute break, then we will do sums. I will ask you to complete the sums when I complete this theory part. I will get a break, but you can do sums, right, at that time. Then write down last part of this one. Multiplication of a matrix by a scalar, here given as a scalar, but write it. Multiplication of a matrix by a whole number. Write down the last theory part of the lesson today. We can't complete the lesson. I told you there are 8 periods lesson, but we can't complete 8-period lesson in 3 hours with fractions, right? We do the lesson 3 hours, but with fraction we can't complete today. The next time I will do matrix multiplication and inequality, the new lesson. All the lessons I will complete, right? There is no way, no other way to complete your syllabus. Then write down multiplication of a matrix by a whole number. 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 Then write in this way. When a matrix is multiplied by a whole number, write down. When a matrix is multiplied by a whole number, when a matrix is multiplied by a whole number, when a matrix is multiplied by a whole number, each element of the matrix, when a matrix is multiplied by a whole number, each element of the matrix When a matrix is multiplied by a whole number, each element of the matrix, each element of the matrix is multiplied by the whole number. Each element of the matrix is multiplied by the whole number. Right. Then now we are going to multiply a given matrix by a given whole number. When you multiply matrix by a whole number, all the element of that matrix should be multiplied by that whole number. All the element should be multiplied by that whole number. Then right here, example 1. For this one, I will give you two examples. Matrix A. Matrix A, I will write square matrix of order 2 by 2 by 2. Square matrix of order 2 by 2. Now I want to find 2A. I want to find 2A. That means matrix A should be multiple by 2. To find 2A, matrix A should be multiple by 2. Matrix A should be multiple by 2. When you multiply by 2, 2 into minus 2 minus 4, 2 into 3 6, 2 into 1 2, 2 into 4 8. All the element of that matrix should be multiplied by 2. Very easy to understand, right? 2A mean matrix A multiple by 2. 2A matrix A multiple by 2. When you multiply a given matrix by a given whole number, all the elements are multiplied. 2 into minus 2 minus 4. 2 into 3 6. 2 into 1 2. 2 into 4 8. It's very easy to find. Now example 2. Example 2, matrix B. Matrix B, I will write in this way, matrix B, 3 minus 1, 0, 4, minus 2, 5. This is a matrix. I want to find 3B. That means all the elements of matrix B should be multiplied by 3. All the element of the matrix B multiplied by 3. Then write it. Matrix B given. Matrix 3B. So, all the element of matrix B should be multiplied by 3. All the elements of matrix B should be multiplied by 3. Multiplied. Matrix B, there are 6 elements in matrix B. Multiply all the elements of matrix B by 3. Multiple by 3. Matrix B multiple by 3. Then we will multiply. No need to get more time. I'm playing this and then we can start to do sums today. We will multiply. 3 multiple by 3, 9. 3 multiple by 3, 9. 3 multiple by minus 1, minus 3. 3 multiple by 0, 0. 3 multiple by 4, 12. We are multiplying all the elements of the matrix by 3. 3 multiple by 3, 9. 3 multiple by minus 1, minus 3. 3 multiple by 0, 0. 3 multiple by 4, 12. 3 multiple by minus 2, minus 6. 3 multiple by 5 is 15. So, matrix B, when we multiply it by 3, answer 3 into 3, 9, 3 into minus 1, minus 3, 3 into 0, 0, 3 into 4, 12, 3 into minus 2, minus 6, 3 into my 15, right? Now I have completed all the theory part of the lesson other than the multiplication of matrix I didn't do. That theory part I have given on my paper separately. Now we should do these fractions. Right. Now try to write the answers for these sums. Now I will give you some time. We will do one by one these fractions. So, okay. I'll give you a time. Now you have complete all the theory part of the lesson. Now I say you multiplication I didn't given. The first 24 sums when you complete, no need to complete the next theory part. Then when I complete the last theory part of the lesson, separately I have given 20 sums. But for first 24 sums, no need to do multiplication of a matrix by a matrix. Then look at the second side of the paper. Start to do these fractions, right? I will give a time. The first fraction, that is a different theory part. I didn't explain you. Therefore, I will tell you how can you do first one. First one mean, look at here as an example. After that, you can do it. I will give you time, right? I will give a break, but first I will explain you. Otherwise, the first fraction you can't do. Write down the transpose of the following and state the order. Then transpose of a matrix. That is not a theory part in our syllabus, but it's a very important theory. That is why I have given, but I didn't explain you about that. What is mean by transpose? Transpose of a matrix. Then look at here. Matrix A, if I write matrix A 2 minus 1 0 5. Now I want to write transpose. Transpose of a matrix means if the matrix is A, transpose of a matrix called A dash. Now I say to you that is not in your syllabus, but if you do this one, some questions I have given, you have to apply this. Then that is very important to know. That is a main part of that lesson about matrices, not given here. Matrix A 2 minus 1 0 5. Transpose represented by dash. A dash means transpose. Then how can you write the transpose? The method, first row. Look at here. Matrix A, first row of matrix A become first column of the transpose. First row become first column. First row become first column. Second row becomes second column. That is all. Transpose of a matrix means when you write the transpose, look at the first row. Always look at the first row. First row becomes first column. All the elements in first row you have to rearrange in the first column of the transpose matrix. A 2 minus 1, that is in the first column. Then second row, second column. First row, first column. Second row, second column. Then write the transpose and write the order of the transpose. 2 rows, 2 columns. Order of the transpose we have to write, right? Complete it. You need to do first fraction onward, right? I will give you a 10-minute time. Right, start to write it. You want to complete before I will start to do these sums. So start to write answers. Within 10 minutes, I will come back and I will explain you answers for this. Start to write the answers. When I explain, you can check your answers. Write down answers. There are 24 sums. Now the time is 10:15. We have 45 minutes to complete at least these 15 sums in the first page. Maybe try to complete. Hurry up, start to do. If you have understood the lesson, very easy to complete this page. Start to do sums. Right. Then I think you have completed the first one. Hurry up. Do these questions one by one. I will do all these sums. Now I told you we will try to complete the first 15 sums. At least 10 questions we will complete today. Then it will take 2 days. I think I told you eight periods. No? Then it will take more time to complete the lesson. Right now, I will start to do these sums. Complete. First one. No need to listen to me. When you are doing these sums, check your answers. Right? No need to stop your work and listen to me. Check your answers. I will explain all these questions. One by one I will explain you. When you are doing you can check your answers. No need stop your work. First one, write down the transpose of the following and state the order of transpose. The theory part of the lesson I have completed, therefore one by one we want to do this question. Write down the transpose of the following and state the order of transpose. First one, question number one. Matrix A is given, then we want to write the transpose of A dash. I told you the method. First row. First row of the matrix A becomes first column. First row 2 minus 3, it becomes first column. Second row 0 4 becomes second column. This is matrix A dash. Matrix A dash means transpose of matrix A. 2 minus 3, 0, 4 become 2 zeros minus 3, 4. Second example, matrix B. Matrix B is a column matrix. Then, when you write a transpose of the column matrix, transpose of the column matrix becomes a row matrix. So, matrix B, transpose of the matrix is a row matrix. See, third part. Matrix C. Matrix C is a row matrix. Matrix C is a row matrix. Then, when you write the transpose of a row matrix, that should be a column matrix. Transpose of a row matrix is a column matrix. Matrix C is a row matrix. Transpose of the row matrix should be a column matrix. Transpose of a row matrix should be a column matrix. Then matrix D, fourth part, matrix D transpose D dash, transpose matrix first row. First row become first column. First row become first column. Second row become second column. Then these are the transpose matrix of the given matrices. The first section I have completed. Then we want to write the order of the transpose. I have given here. Write down the transpose of the following and state the order of the transpose. Then first matrix, order of the transpose. When there is a square matrix, transpose matrix also in the same order. Order of the transpose is 2 by 2. Second matrix, order of the transpose should be 1 by 2. One row, two columns. First matrix, 2 row, 2 columns. Second matrix, 1 row, 2 columns. Third one, 3 rows and 1 column. Order of the matrix C, 3 rows and 1 column. Order of the matrix D, 3 rows and 2 columns. You want to write the transpose of the matrix and order of the transpose. Then matrix A dash, transpose of matrix A is A dash, order of the transpose 2 by 2. Matrix B, order 1 by 2. 1 row and 2 columns, 2 row and 2 columns, 3 row and 1 column. Then here also 3 rows and 2 columns. That is the answer for question number 1. Question number 2, find where possible. Find where possible mean if you can add given matrices. Find where possible mean if you can add two matrices. You know that if you want to add two matrices, the order of the two matrices should be same. But when you look at these three questions, four sums, order of the matrices are same. Therefore, all the matrices can be added. They are in the same order. That means all the matrices can be added. Question number 2. No need to write this question. Write the answers at once. First part. When you add two matrices, the order of the answer should be 2 by 2 because you are going to add two square matrices. Then 6 plus 4, 10. 3 plus 1, 4. 10, 4. 1 plus 3, 4. 2 plus 2, 4. The first one answer 10, 4, 4, 4. The second question, there is a mistake because I didn't separate these matrices. In here, there are two row matrices, order 2 by 1. 1 minus 4 is a 1 matrix, then minus 3, 6 is the second matrix. Addition sign is given, but I didn't separate the matrices. Second one, 1 and minus 3 when you add, that is minus 2. Minus 4 and 6 when you add, that is plus 2. Question number 2, answer minus 2 and plus 2. Minus 2 plus 2, two element of the row matrix, column matrix of order 2 by 1. Answer is a column matrix of order 2 by 1. Then element minus 2 plus 2. Question number 3. Then again there's a mistake. I didn't separate. The line is not given between two matrices. So then there are two column matrices of order 3 by 1. Then minus 1 and minus 2 added, that is minus 3. Minus 3 and 0 is added, that is minus 3. Plus 4 and plus 2 is added, that is plus 6. That is enough. No need to write fraction. No need to write that question. If you write the answer, that is enough. Fourth one, two matrices should be added. When you added two matrices, corresponding elements are added. 3 plus minus 1 is 2. Minus 1 plus 4 is 3. 1 plus 3 is 4. The second row plus 1. 1 and 5 and 0 is 5. 6 and minus 6 equal, when you added 0. Minus 7 minus 5 is added minus 12. Then these are the answers for question number 2. If you can add two matrices, you have to add it. When you add matrices, these are the answers for this question. Right. Now you have to do question number 3. Third one, the element you have to subtract. Corresponding element should be subtracted. Subtract element. Question number 3, like we did addition here, like this, you have to subtract. No need to write the fraction. Subtract elements. Third one, first part. Subtract and write the final answer at once. No need to write this step. Subtract and write it. Find where possible. 3 minus 2 minus 1, 3. You have to subtract this element. Subtract the elements. Question number 3. Right. Question number 3. We will subtract corresponding elements. So first one, 3 minus minus 1. 3 minus minus 1 is 4. 3 minus minus 1 is 4. Minus 2 minus 3 is minus 5. First part answer should be 3 minus minus 1 is 4. Minus 1 minus 2 minus 3 is minus 5. Second one. Second part. Corresponding element should be subtracted. 4 minus 3. 4 minus 3 is 1. 4 minus 3, 1. 2 minus 4 is minus 2. 2 minus 4 minus 2. 1 minus 0 is 1. 1 minus 1 is 0. At once write the answer. Third part. Corresponding element should be subtracted. 4 minus 2 is 2. 4 minus 2, 2. 5 minus 1, 4. Corresponding element. 3 minus 1, 2. The elements in the first row. Second row. 1 minus 4 is minus 3. 1 minus 4 minus 3. Minus 2 minus 1. Minus 2 minus 1 minus 3. 1 minus 2 is minus. Question number 2 answers 3. Sorry. Question number 3 first part, second part, third part. Fourth one. There are 4 parts in question number 2, 3. In next row is given that. That is, then consider about the element. The negative values are given. More values are negative. Minus 1 minus minus 4. Minus 1 minus minus 4. minus 1 plus 4, that is plus 3. Second, 2 minus minus 2, 2 minus into minus plus, 2 plus 2 is 4. 3 minus minus 1, 3 minus into minus plus, 3 plus 1, 4. Next one, 5 minus minus 3, 5 minus minus 3 is 8. Now I have completed first three questions. Then you can check your answers for first three sums. Check your answers for first three. If you didn't check, check your answers for first three questions. First three sums I have completed. First three I have completed. 10, 4. Sorry, here third one, 4 minus 5. Second part, 1 minus 2, 1, 0. Third part, 2, 4, 2, minus 3, minus 3, minus 1. Fourth part, 3, 4, 4, 8. Then you have seen this matrix. This is a type of the matrix you have learned. That is a square matrix. That is a symmetrical matrix. And look at this one. The third question, the last answer. That is a square matrix because order 2 by 2. Then this is a main diagonal. Then elements around the main diagonal, they are equal mean. That is symmetrical matrix. Now the question number 4. First three sums we have completed. Then we are going to do fourth question. Complete question number 4. Question number 4. I will remove this one, right? Check it. If you have checked the answers. First question, there are 4 parts. We have write the transpose of the matrix and the order of the transpose. Second, we should add matrices. We should write only the answer, no need to write the calculation method of question. Third one, we have subtract matrices, corresponding elements subtract. I think you have checked these sums. Now we will do question number 4. Fourth one. Fourth one. When I do these lessons at my normal classes also, I know that I have done all these questions. I have done all these questions when we complete it. Otherwise, if there is any difficult one, if I didn't explain, you don't know what is your mistake and you don't know how to do it. So I want to explain all these questions. Now we are in fourth question, first part. I have defined two matrices A and B. Two matrices A and B I have defined. First you want to write A plus B. If you write the answer at once, it's okay. But I will write the step. No need to write the step if you write it at once. This is matrix A plus matrix B. If you want to add two matrices should be in the same order. Then only we can add two matrices. Matrix A 2 by 2, matrix B also 2 by 2. Elements in matrix A minus 1, minus 2, 0, 3. Matrix B 3, 1, 5, 3. Now A plus B. Sum of the two matrices minus 1 plus 3 is plus 2. Minus 2 plus 1 is minus 1. 0 plus 5, 5. 3 plus 3, 6. That is the answer for first part of question number 4. Two matrices should be added. They are in the same order. Then we can add them and corresponding elements are added. Question number second part of that one. We want to find A minus B. A minus B. So matrix A minus matrix B. Matrix A minus matrix B. Answer, when you subtract, minus 1 minus 3 is minus 4. minus 2 minus 1 is minus 3. 0 minus 5 is minus 5. 3 minus 3 is 0. Question number 2, minus 4 minus 3 minus 5, 0. Third part, we want to find b minus a. Now I told you, if you have calculated this fraction, do next one, then next one. Like that, all these fractions you have to complete. Then when I do check your answers, no need to listen to me, but if you find any typical one, if you didn't know how can you do this, then you can listen to me. Otherwise, don't get time. Only check your answer, then write the answers. Next one, b minus a. First, I want to write matrix B. Then, I want to subtract matrix A. Matrix B minus matrix A. Corresponding element should be subtracted. Then answer 3 minus minus 1 is 4. 3 minus minus 1, 4. 1 minus minus 2 is 3. 5 minus 0 is 5. 3 minus 3 is 0. Then I have complete question number 3 with all this step. Check your answer. Question number 3, sorry, question number 4, I have completed all the steps. If you write the answer, only answer, it's okay, right? If you write the final answer this way, that is enough. No need to get a time to write the question. But when I write, I will write it to understand. If you didn't get the correct answer, then you know what is your mistake. Question number 5, fifth one, first part. Fifth one, first part. Okay. Fifth one, first part. We want to find A plus B plus C. Three matrices should be added. First part, A plus B plus C. Second part, 2A minus 3B. 2A minus 3B. Third part, complete then check. A plus 2B minus 3C. Matrix A, 3, 2, 3, 2 plus matrix B, minus 1, 4 plus matrix C, minus 3, minus 1. Matrix A, B and C. In the first part, we want to add these three matrices. So we want to write what is A plus B plus C. We want to write sum of these three matrices A plus B plus C. Answer plus 3 minus 3 0, then minus 1 remain. 2 plus 4 6. 6 minus 1 is 5. So answer for A plus B plus C, that is a column matrix of order 2 by 1. Elements minus 1 5. Elements minus 1 5. Question number 2. 2 times matrix A. 2 times matrix A minus 3 times matrix B. 2 times matrix A minus 3 times matrix B. Then the method is multiplication of a matrix by a whole number. When you want to multiply a given matrix by a whole number, all the elements of the matrix should be multiplied. Then we are right here 2 times 2 into 3 6, 2 into 2 4. 3 times. If you multiply by plus 3, then this minus sign is remain unchanged. If you multiply by minus 3, this sign become plus. Then if you want, you can put this plus sign and multiply by -3. If you put minus sign, you have to multiply by +3. I will keep this sign without changing. So I want to multiply that matrix by +3. Plus 3. 3 into -1 -3. 3 into 4 12. So now you want to subtract two matrices. To find the answer, two matrices should be subtracted. So 6 minus -3. 6 minus into minus plus 6 plus 3 9. Then 4 minus 12. 4 minus 12 minus 8. Question number 5, second part. 2a minus 3b is equal to 9 minus 8. 2a minus 3b, 9 minus 8. 9 minus 8. Third part. A, matrix A, 3 2 plus 2 times matrix B minus 3 times matrix C. It's a calculation. Matrix A we didn't change. Matrix B multiple by 2. Matrix C multiple by 3. Then first we want to multiply these two matrices by the given whole number. Then finally these two added and this one should be subtracted. First you want to multiply matrix 2 and 3. For matrix 2 by matrix B here. Matrix B by 2. Matrix C by 3. Then find their product. Matrix A 3 2. Matrix B multiple by 2. 2 into -1 minus 2. 2 into 4 is 8. Minus. I told you you can multiply by -3, then sign become positive. If you multiply by +3, the sign should be negative. Minus 3 into -3 -9. 3 into -1 is -3. If you multiply by -3, this value become positive. If you multiply by +3, these two value, this here remain minus sign. Then answer, numerators added 3, sorry, the first value is added 3, 3 minus 2 is 1, 3 minus 2 1, 1 minus into minus plus 1 plus 9 is 10. Then check your answers. If you have done it correctly, then good, you have learned it well. Then 2 plus 8 is 10. 10 minus into minus plus 10 plus 3 is 30. Question number 5. Answers. First one 9 minus 8. Second one, sorry, first one -1 5. Second one 9 minus 8. Third one 10 30. Complete question number 6. Complete sixth question. Sixth one, do it. Hello. Oh, my God. Isa kata ko. Wala ka kalaman. Kiyos. අයවසරයි අටවසරයි නේ පොඩක් මේ මට කියන්නකෝ නම් දෙක නෑ 10 නම් මේකද WhatsApp තියෙනවද මේ නම්බර එකේ එහෙනම් නම් දෙක කිව්වනම් හරියි අටවසරෙන් කියලා KP නේ Minuki Minarani. And the high was KP Kavishkari. Kavitra Kitnikari. Hari. Hari. මම දැන් මේ නම්බර් එක ඇඩ් කරලා එන්නොත් මේ ගෲප් එකට දාගෙන පේපර් එකේ වන්නම් මම. මේ පේපර් එක මේ පේපර් එකේ කොපි එකක් අරගෙන තියාගන්නම්. අටවසර එක තියෙන්නේ මම හිතන්නේ බදාදා හරි බ්‍රහස්පතින්දා හරි මම ටයිම් ටේබල් එක පොඩ්ඩක් බලන්න. හරි. okay. Right. I should give you a time to complete, otherwise if I do all this section without completing you, that is not good. Anyhow, today we can complete 2 more sums, 1 section more. 6th one we will do today. When you come next day, complete up to 24, I think. Yes, up to 24 section you have to complete. The multiplication I didn't do, no, then the other section you can't do. Right? Then if you complete this section, when we do the class next time, if you complete this 24 section, very easy to complete the lesson, because all the sums I will do, then you have to check only. After that, the second part of the lesson we can complete. Now question number 6 we will try to do. 6th one. I will get a time to complete the lesson, otherwise if I do all this question quickly, then that is not used. You should complete first. Question number 6. First part, you want to find x. X is equal matrix A 0 3 plus matrix B -5 -1 plus matrix C 1 4. Then second part, x is x plus A. I will make x as a subject. X equal B minus C minus A. Then we want to find x now. They have given x plus A. X plus A equal B minus C. I will write it anyhow. X plus A. X plus A equal B minus C. X equal B minus C minus A. So x we want to find. Matrix B. Matrix B is -5 -1 minus matrix is 1 4 minus matrix A 0 3. Then we have to simplify and find the answer. Third part, we want to find C minus A. C minus A equal B minus X. We want to make X as a subject. So minus X, I will get into left hand side, then minus X become plus 6. Here B, minus A take into right plus A, plus C take into right minus C. If you want to find x, we have to make x as a subject. First one, x as a subject, that is given, no need to change. Second one, x make into subject. So right hand side b minus c minus a. Third one, when you make x as a subject, that is equal b minus a become plus a minus c. So matrix B -5 -1. Matrix A 0 3. Matrix C 1 4. Now we will simplify this. The next one we can do, therefore we will complete this one quickly. So here matrix ABC, when you add answer 0 plus minus 5 is minus 5. Minus 5 plus 1 is minus 4. So minus 5 plus 1 is minus 4. 3 plus minus 1 is plus 2. Plus 2 plus 4 is plus 6. So the first one answered minus 4 plus 6. First one answered minus 4 plus 6. Minus 4 plus 6. Second one, x plus a equal b minus c. So x equal b minus c minus a. When you subtract minus 5 minus 1 minus 6, minus 6 minus 0 is minus 6. Minus 5 minus 1 minus 6, minus 6 minus 0 is minus 6. Then minus 1 minus 4 minus 5, minus 5 minus 3 is minus 8. Minus 8. Question number 3. Question number 3. When you subtract minus 1 plus 0, minus 5 plus 0, minus 5. Minus 5 minus 1 is minus 6. Minus 5 minus 1 is minus 6. Minus 1 plus 3 plus 2 plus 2 minus 4 is minus 2. That is question number 6. And you know that the theory part is different. When you didn't learn matrices in earlier grade, no, then you are learning matrices first time in grade 11. Then I told you this is very important for grade in 11 classes. If you do maths, you have to learn it again. Therefore, understand well. The first theory part of the lesson we have completed. Then now we did 6 sums, but in the first part there are 24 sums. In the second part there are 20 sums. Then from O-level exam sums, I have collected 13 questions, all the questions given in O-level exam from 2018 to 2009. Then next day we can complete O-level sums too. Without doing multiplication, we can't do it. Right? Now, question number 7, I will do as the last question. Now, check your answers for these sums. First one, minus 4, 6. Second, minus 6, 8. Third, minus 6, minus 2. Without removing this one, I will write 7th one as the last question. It's question number 7. 7th one. Minus 7. Then they have added 2 matrices. Then they have got the answer. 2 matrices added, then the answer is given. We will write corresponding element addition. First row, first element. First row, first column. First row, first column minus 7. Matrix 2, first row, first column y. Result, first row, first column minus 5. We can form simple equation minus 7 plus y equal minus 5. So, y equal minus 5 plus 7, y equal plus 2. Then we want to find x. So, first row, second column x plus matrix, second matrix, first row, second column is minus 2. Then minus 7 plus y equal minus 5 when you get the second element of the 3 matrices. X plus minus 2 equal 3. So x equal 3 minus 2 in right hand side plus 2, 5. Then like that, some questions are very easy to understand. And question number 7 is not difficult. Question number 6, that is somewhat difficult because we want to make x as a subject. After that, we have to substitute matrix A, B, C. Then we have to simplify the given question. Right. Now, I have then today the first online lesson I have completed today. Then I told you at the beginning of the class too, you have to complete 9 lessons in third term test and for your O-level exam. Then you have no way to learn these lessons at the school. Then normal tuition classes also we can't do. But completing the O-level, completing O-level math syllabus is very important for A-level. Then if you can't complete this lesson, then the O-level exam they have decided to do on 15th of January. But if you didn't complete the lesson, they will make your paper simple. But you know, if you didn't complete this syllabus, then it will be a problem for you in A-level exam. So the last 7 lessons in your O-level syllabus in mathematics is very important lesson. They are very important lesson. Therefore, anyhow, you have to complete these lessons. That is why we are doing some classes. Then I have increased the time period. The time. Normal classes we did only 2 hours, but from today, online classes I will plan to do 3 hours. Then please inform your friends those who didn't join with the class today. Inform them how can they join with the class. Then the next day we can complete this lesson the next Monday. If there is any problem about the time, tell me. Then this is not a fixed time, we can change this time. Inform to your friend, and if you have any problem about joining this online class this time, please inform me. Then I have done 3 grades 11 classes. Then I want to join all these students to same class to complete this syllabus. If we didn't complete your syllabus, there is a problem. At the schools, we have given some papers through WhatsApp in the second term, but this time they don't have any plan. They don't try to complete the syllabus. They can't get that responsibility. So, as a teacher, as a tuition teacher, we should give some. We should help you to complete the syllabus. Otherwise, we didn't consider about our responsibilities, right? Please inform your friend about this class. The next Monday, 8 to 11, I have planned. If there's any change, I will inform you through our website and through our WhatsApp groups. So now time I have completed. When you come next day, when you join with our online class next time, you have to complete first 24 sums. Already we have completed 7 sums now. Then the remaining fraction complete. When you come next day, complete it. You have enough time to do all these sums. After that, I will write the answers for remaining fractions on the board to check your answers. Then we will do second part of the lesson. I think between 1 hour, 1.5 hours in next time, we can complete the syllabus. After that, there is a simple lesson in your textbook in next lesson. That is inequality. I will give you all the O-level exam sums and we will complete this next time, right? So we will stop now. Right, thank you.